Hello and welcome to this video for question 2b for the Scholarship Calculus exam for 2022. So we're going to consider the triangle ABC shown with AB is length 16, AC is length 12, the angle of ABC is A, the angle of ACB is 2A. And we want to find the exact area of the triangle. So we're going to find the exact area. So let's write out an expression for the area of the triangle so we know exactly what we're looking for straight away. So in terms of the area, we can look at this angle here and this side AB with angle C. And we know that the area is equal to 1/2 of AB sine of C. And that is equal to 1/2 of 16 times of 12 times of sine of 180 minus 3 alpha. Because angles in a triangle add up to 180 degrees. And we know that in this case, we probably can use radians instead. It's probably preferable. If we're working with the exact form, probably we should change that to pi minus 3 alpha. Apologies. Change it to pi minus 3 alpha. And one of the identities for sine is that the sine of pi minus x is equal to sine of x. So therefore, this is actually equal to, the area is equal to 1/2 of 16 times of 12 times of sine 3 alpha. So let's leave that for now, and because we need to find an expression for alpha, and we can use that using the remaining angles and lengths we have. So let's use the sine rule. So in terms of the sine rule, we have, we can say looking at this angle here, and this length here, and we can look at angle ACB here, and we can look at length AB. So in this case, we have sine of alpha divided by 12 is equal to sine of 2 alpha divided by 16. So we can say that 16 sine of alpha equals to 12 sine of 2 alpha. And we can write sine of 2 alpha as 2 times of sine alpha times cos alpha. So we have 16 sine alpha equals to 24 sine alpha cos of alpha. So we can solve this in terms for make it equal to 0 and solve for alpha. So we have 24 sine alpha cos alpha minus 16 sine alpha equals 0. So if we can factor out sine alpha, so that leaves us with 24 cos of alpha minus 16 equals 0. So we have sine alpha equals to 0, or we have cos of alpha equals to 16 over 24, which is 2 over 3. The solutions for sine alpha equals to 0 is alpha equals to 0 and alpha equals to pi. And both of those are geometrically impossible given the triangle we have. So let's just ignore sine alpha equals to 0. That's not going to give us any decent solutions. Let's look at cos alpha equals 2 over 3. That's going to give us a pretty good solution for our alpha. It's going to be pretty reasonable and will fit geometrically. It's geometrically possible. So let's consider cos alpha equals 2 over 3. If the question did not require us to use the exact area, we can just find an approximate decimal form for the alpha and then plug that into our equation for the area. However, the question is pretty pedantic and it wants the exact area of the triangle. So there's a couple of things we do need to do in terms of trig identities. In terms of seeing what we need, so what we need is we need 1/2 of 16 times of 12. I'll just evaluate that so I don't have to keep writing it. So 96 times of sine 3 alpha. And we have cos alpha equals to 2 over 3. And we can use sine squared alpha plus cos squared alpha equals to 1 in order to evaluate the exact form of sine alpha. So in terms of what we need here, so we have sine of 3 alpha. It's pretty hard to get this exact form of what we have now. So it's really good to get sine 3 alpha in terms of just sine alpha and cos alpha, which we will already have. So we can rewrite sine 3 alpha as sine of 2 alpha plus alpha. And using our sine rules and for our angles, we have sine 2 alpha plus alpha, that's equal to sine of 2 alpha cos of alpha plus of cos of 2 alpha sine of alpha. And we can continue to reduce this by saying that sine 2 alpha equals to 2 sine alpha cos alpha. And we can say that cos 2 alpha equals to 1 minus 2 sine squared of alpha. And we can continue to simplify. So we have 2 times of sine alpha cos squared of alpha plus 1 minus 2 sine squared of alpha times sine alpha. So that equals to 2 sine of alpha cos squared of alpha. We have plus of sine alpha minus 2 sine cubed of alpha. So now we have our equation in terms of only sine alpha and cos alpha. So let's find exactly what sine alpha is by using our trig identity. Sine squared of alpha plus cos squared of alpha equals to 1. So we know that sine squared alpha equals to 1 minus 4 over 9, which equals to 5 over 9. So therefore, sine alpha equals to root 5 over 3. Perfect. Okay. So let's evaluate this expression, 2 sine alpha cos squared alpha plus sine alpha minus 2 sine cubed alpha. Let's get that going. So we have 2 times of root 5 over 3 multiplied by cos squared of alpha, which is 4 over 9. We're going to add that to sine alpha, which is root 5 over 3. And we're going to subtract 2 times of sine cubed alpha. So that's going to be sine squared alpha, which is 5 over 9, multiplied by root 5 over 3. So let's simplify a bit here. So we have 8 over 9, 8 over 27, root 5. Let me just double check that. 8. Yep, 8 over 27 root 5 plus root 5 over 3 minus, in this case, we'll have 2 times of 5 root 5 over 27. And that will just be 10 root 5 over 27. Let's simplify this a bit more. So 10 root 5 over 27. 10 root 5. Alright, so let's simplify this since we have everything in terms of root 5. So we have 8 over 27 plus 1 over 3 minus 10 over 27. That's going to give us 7 root 5 over 27. And that's really nice because now we have an expression for sine 3 alpha and we can just chug it into the area. So the area is just simply 96 multiplied by 7 root 5 over 27. And that's going to give us 224 root 5 over 9. And that should be our final area of the triangle. And we can just leave it as 224 root 5 over 9. And that is our final answer. So the challenge for this question, I think it's mainly, I think it's pretty easy to work out in terms of just getting the non-exact area is pretty easy. But in order to figure out the exact area, I think the couple of challenges you needed to do was to figure out cos alpha and sine alpha. And then the next challenge was just rewriting sine 3 alpha in terms of just sine alpha and cos alpha. So you can make your substitutions easy. And other than that, it's nothing too hard. It's just some basic algebra there to get your final answer. So I hope you enjoyed this video and I hope to see you all in question 2C.